Hello everyone, this is a video lecture for Calculus 3, section 15.5, surface area. And here's your formula. Surface area is double integral over a region of the square root of 1 plus f sub x squared plus f sub y squared dA. So, you know what's pretty cool is that this formula here is very similar to the other formulas we had in Calculus 2, something kind of like f prime squared dx or something like that. It was something similar. Maybe there was like a 2 pi or something else in there. But this formula has been around for arc length, and so we're also now doing it for surface area. It's the same kind of stuff. So let's just jump right in immediately. 155005. Doesn't look like a 5, but you know I said that, so there you go. It says find the surface area. We have a plane that is 13x plus 2y plus z is equal to 26. And we're looking at the first octant. First octant. Okay. So first off, I need to find out what my little f is. And really, I just move this stuff over to get my z, or f. It's equal to 26 minus 13x minus 2y. So these z or f are synonymous. They're the same thing. So f sub x, when I do a derivative, would be negative 13. F sub y, when I take a derivative, is negative 2. Using this stuff, my surface area then, like my answer, would be double integral over that kind of region, the square root of 1 plus, negative 13 squared, negative 2 squared, and then dA. So this is what I'm really going to find in the end. Obviously, this here turns into just a scalar, a number, which is not too bad there. I think it's actually the square root of 174. So square root 174 in the front, double integral dA. So we're looking for that area that is the shadow on the xy plane, and then you're multiplying it by the square root of 174, and you're done. So what does this thing even look like? So xyz, we have a plane here. If you start setting your x's and y's equal to 0, so like if you set x and y equal to 0, you'll get z equal to 26. So 26 is up here. If you set your x and your z equal to 0, you'll find your y is equal to, I think it's 13. Yes, 13, which is about right there, let's say. And then if you set your y and z equal to 0, you'll solve for x, and if you solve for x right there, you'll find it's just simply 2. So what happens is that this plane is something that looks like that. This is my plane. And really, we're wanting the surface area of that plane. The 2D version of this, if you're looking down straight on the z-axis right here, what it looks like that I've drawn as first octant is up here at 13, and then down here at 2. And there's like this triangle right here. But remember what I just said. I said we're taking the square root of 174 and multiplying it by the area on the xy plane. So if you wanted to find the area here, well, it's the area of a triangle, right? 1/2 base times height. The 2's cancel, and you get a 13, right? So simply put, my answer is 13 square root of 174, and you're done. Of course, I want to go and actually do this integral and want to show you what's going on. But here's the thing. This is real world stuff, I guess you can say. It's if you know what you're doing, you can really cut corners. You don't have to go the full length every time. What I did, and maybe it is a little silly, is I said, well, the double integral 0 to 2, 0 to negative 13 over 2x plus 13 of the square root of 174 dy dx. Notice what I've done here is made a line. I made this line right here. And you can see that basically I would have a slope. I find a slope, and then I find my y-intercept, and etc. Top and bottom, all that stuff. So, I mean, really, you go and do all this math, and it will eventually come out to be the same thing. But you can do either way. I don't want to waste your time on it. I think it's not too hard of a problem. Let's keep moving. Just wanted to show you an alternative to accomplish that. Okay, so this one we have a paraboloid, which is z equal to 1 minus x squared minus y squared. Okay, and they say above the plane z equals -4, and they want to find the surface area. So what's the surface area of that shape? So we got a paraboloid that's upside down, and then we got a plane there. So we got a paraboloid upside down. It's kind of like a cup or a bowl or something, and it's upside down. And then I have this plane here at z equals -4. And so then basically it's making that circle shape as it's hitting this plane, and they're wanting to know what is the surface area of this like dome, here, dome. So yeah, what is that surface area? Well, first off, f is equal to z is equal to 1 minus x squared minus y squared. So f sub x is a -2x, f sub y is a -2y. With that in hand, my surface area is going to be double integral of the square root of 1 plus -2x squared, -2y squared, I guess dy dx is good enough. You can see here that it's going to be a lot more complicated than the last one. Not that that's bad. It's just fun and interesting now. dy dx. Okay. So how do we keep approaching this here? Well, first off, I need to find out what I'm going to be putting up there for my limits. But here's the thing. When I'm going back and looking at this, it looks like a circle. I feel like I have this x squared plus y squared going on here. What if I went to polar form? And so in a way here, I'm saying my x squared plus my y squared is equal to r squared. So there's something. And with that in hand, I want to see if I could find out what that shadow is going to be, this area right here, that shadow that's, casted down from my dome. There's your sun, I guess, and there's your shadow. What would that shadow be? Well, basically I need to take these guys and set them equal to one another. You see that? And so let's go and do that right quick. I've got -4 is equal to 1 minus x squared minus y squared. If you take these and move them over, take this and move it over, x squared plus y squared is equal to 1 plus the 4, which is 5. And so what you're getting here is in polar mode, r squared equals 5, thus r equals the square root of 5. Because again, like I said, it was a circle. So that circle is going from 0 out to square root 5. So let's go and do this. And I'm also going a full circle, 0 to 2 pi. And this is where it kind of changes a little bit. Notice that I can factor the 4 out to the front of these two guys here, leaving x squared plus y squared, which is an r squared. Now, when you're going into polar mode, remember the requisite r, dr, d theta. You need that requisite r right there, okay? And it's actually super required because if you're going to do u substitution, you got to have that. U is equal to 1 plus 4r squared, du, bring the 2 down, 8r dr, and so dr is du over 8r, using those two right here. Integral, I would say that's going to be the square root of u, r, du over 8r, which these guys are going to cancel, d theta. The 8's going to come to the front. And so when I integrate my u, I'm now going to say that's 1/2, add 1 to the power, divide by new power, 2/3 u, now to the 3/2, from 0 to square root 5, d theta. Okay. So, of course, I'm going to toss this in. This is 0 to 2 pi, by the way. Toss that square root 5 in. Also notice I do have to plug in that 0 to get more of an answer. And so plugging in the square root 5, square root and square cancel. 4 times 5 is 20, so I get a 21 essentially. So 21 to the 3/2, When I plug in a 0, it only just goes to 1, and 1 to the 3/2 is just 1. So you don't have to worry about that. D theta. All of this here is a constant that you can also toss to the front. 1/8 times 2/3 times 21 to the 3/2, and then minus 1 there. Times the integral, 0 to 2 pi d theta. Another professor that does Calculus 3 a lot likes to call this the 2 pi slide. Essentially, whenever you're encountering something like this and there's no other thetas, you could just simply say that it's times the 2 pi. I kind of like the terminology. So you just say, oh, times 2 pi. It's pretty fast. Anyway, so a lot of these cancel and combine and stuff. Kind of leave this part alone right there. And it ends up being, in the end, 1/6 pi of this 21 3/2 and then minus 1. So there you go. All right, next one. 15,5,011. I got z is equal to x times y. And they want to say, okay, well now inside of the cylinder, I didn't spell cylinder very well, did I? X squared plus y squared equals 36. And they say, what's the surface area of this guy here? Okay, well, it's kind of convenient that I already have this set up. And so then I can say f sub x is a y, and f sub y is an x. It's kind of funny how that works. So surface area is double integral of 1 plus y squared plus x squared dA. And again, we could just see that there. You know, whenever I see the cylinder going on and you can see this, like, what is this radius here? It's going to be, what, a 6? You can already start thinking that it's going to be polar mode. That's at least what I start thinking to see. Again, inside the cylinder is pretty easy to see. I mean, yeah, we can make a cylinder, and that's fine and all. But what's that shadow is a circle with a radius of 6. So I could just say, okay, a full circle, 0 to 2 pi, radius all the way to 6 of, and now 1 plus this guy right here turns into an r squared, r, my requisite r, dr d theta. And so just like the last one, you're going to do u substitution on the inside. You're going to end up with the half coming to the front. So integral 0 to 2 pi, integral u to the 1/2 du d theta. Whenever you take your integral, it would be the 3/2 and then divide by that new power. Make it 2/3 in the front, essentially. We've seen this. This is no different. From 0 to 6 d theta, when you plug in the 6 and plug in the 0, you get numbers in both cases. Of course, now you're going to get 6 squared is 36 plus 1 is 37. And then 1 to any power is still just going to be a 1. 2 pi slide. And so you can see that our answer is very similar to the last problem. When you start combining stuff here on this, trying to jump ahead of here a little bit, 2/3 pi 37 to the 3/2 minus 1. So there we go. All right, another one. 15,5,014. So they're wanting the surface area here of part of a sphere, and this sphere is really weird. I'll show you what I mean by this. Z squared, so x squared y squared z squared equals 4z. And then they also say that it has to be inside the paraboloid z equals x squared plus y squared. Now, I went to go look up the, I guess you could say like the cheat sheet for this, the solution manual, and they did a lot of assumptions and stuff, and they were going kind of left field in my opinion. I don't really agree with them. So what I want to do here instead is I want to go right to things that we recognize, okay? So I recognize that I could do these tools back from Calculus 2, Calculus 1, pre-cal, algebra, stuff like that. So what I want to do is I want to get right here a z equals, okay? Once I get z equals da-da-da-da-da, then I could simply go and say, oh, well, that's equal to f, and then I can go and do my fx and fy and all that stuff. Lots to do, but I have to start with this, and that 4z is really throwing me off. If it were just a 4, fine, but 4z really is annoying. What you want to do is bring it to the other side. And so we got z squared minus 4z plus something minus something equals 0. What we're doing here is complete the square. So that's an old tool of ours. Negative 4 over 2 is a negative 2. Try to write that a tiny bit better. And then you take that negative 2 and you square it to make a positive 4, which goes here and there. Rewriting. Plus 4, minus 4. And this here makes a perfect square. Z minus 2 squared. I'm going to toss that 4 on the other side, I think. Yeah, that seems fine. Okay, so I want to get z by itself. I'm going to toss this stuff over here as well. Z minus 2 all squared equals 4 minus x squared minus y squared. How do you get rid of the squares? You square root both sides. And I know that it's going to start looking a little ugly. And square root, you're going to have a plus and a minus, right? And of course, add 2 to both sides. That's now going to be on the outside. Okay, now here's the thing. We can't go and do this whole problem with a plus and a minus. So go back up. We're looking for this sphere that's inside of this paraboloid. And the paraboloid is positive. It's shaped up. Okay, that's a paraboloid. Parabola up. It's like a cup. It's holding water. And then the sphere is actually centered at the origin. It's right here. So we got a sphere right there. Like a ball. And they're wanting to know what is that part of that sphere that's inside of this portion here. Let me try to highlight what I'm talking about. Right here, there's this circle going on inside of the paraboloid, and it has this hump on it. So it's kind of hard to see, but it's basically like kind of like a hat. It's like a little beanie hat, I guess, kind of like a low one, like this on the side, kind of. Like if this is XY plane and this is Z. So it kind of has like this little hump that we're looking for. Something kind of like that, okay? Of course it's above the XY plane. Notice that it's positive, you know, and so that's going to be important to us because now we only need to look at the positive answer there, okay? So keep it just positive and we can keep rolling. So we finally got Z, which is now also equal to F. And so then I can do my derivatives. So here we go. This is a big 1/2. Comes to the front. Leave the inside alone. These are derivatives here. And now it's a negative 1/2 power. Derivative of the inside is a negative 2x. That 2 goes away. So simplifying just a tiny bit, these 2's are actually going to cancel. And that negative comes to the front with the x. The bottom, this is now a square root down here. Okay. And there we go. That's good enough. For my fy, you could probably suppose it's going to be something very similar. Oops. So I'm just copy-pasting it, except for that numerator change. And so finally, surface area, what is it going to be? Double integral of the square root of 1 plus both of these guys squared. Whew, it's a lot to type, isn't it? And then dA. Well, the squares for those are definitely going to clear some things up. So let's do a little bit of simplifying before we can jump into more stuff here. So when I square it, the negatives are going to go away. X squared, Y squared, both in the top. Cool. You can also see that they have a common denominator, so might as well go ahead and do that. Oh, and the square will cancel with the square root. There we go. So that's a little bit better. That 1 right there can definitely be simplified, changed to be 4 minus x squared minus y squared in both the top and bottom. And therefore, you would have a common denominator for everything. Just doing some math here to simplify. You can see that these guys are going to cancel. Those guys are going to cancel. The square roots for both of them. And so I say square root of 4 is simply a 2, and then we still have the square root in the bottom. Okay, now that's a lot better. That's going to be our integral that we're going to have to find. Now here's the part that changes things. I need to now go to polar mode. Yet again, if you go back to what we're looking at, it's going to end up being some kind of a circle shadow. Again, what's the shadow here? So it's basically going to be a circle. I don't know what that circle is going to be, but I know it's going to be circle-like, so I'm guessing I'm going to go to polar. In the end, I have, looking back, I got a z equals the positive square root of 4 minus x squared minus y squared and then plus 2, right? And then I also have z equals what? Let's go back up to the very top. Notice right here, z equals x squared plus y squared. Well, that's r squared. In polar mode, that's r squared. So z also equals r. If you convert this into r as well, r squared, so what you're looking at now is z is 4 minus r squared plus the 2, and it's also equal to r. See, because you also have it equal to r, so the z's are also equal to r. And I can take this now and solve for r, which will give me the bounds for my double integral. So first off, let's move that 2 over. So I got the square root of 4 minus r squared is equal to r minus 2. Square both sides. I'm going to FOIL that one out. And then we want to start combining terms and trying to figure it out here together. Actually, I messed up one thing. One thing right here. Hold on. This was r squared. It's not just r. Remember I said it. I said it up here. I said, hey, this is right here. This is equal to r squared. So hold on. Watch the video to the end always, right? R squared, r squared, r squared, r squared. And now this changes a tiny bit right here. Go ahead and change it a little bit here. The numbers are about the same, of course. It's now r to the 4th, and that's an r squared. Okay. Whew. So we're getting really close. I'm going to now move this stuff over to this side. We've got r to the 4th minus 4r squared plus the 4 plus r squared, and then minus 4 equals 0. These guys cancel. These guys combine. R to the 4 minus 3r squared equals 0. I can factor out an r squared to the front, leaving r squared minus 3. And then you can see here that I'm definitely getting r equals 0. Here you would get r equals plus or minus square root 3. But yet again, as a radius going out from 0, square root 3 should be good. So now back to my integral. It's a full circle, 0 to 2 pi. My radius is going to be from 0 to square root 3 of 2 over the square root of 4 minus r squared. If you go back up to my surface area formula here, notice again that's r squared, right? And then my requisite r, dr, d theta. Again, using the u substitution stuff. Sorry that my r's and u's kind of look similar. Basically a negative 1/2 in the front. And so what I have, oh, and the 2 actually can come out as well. So, you know what? I'm going to put a 2 right there. That'll be fine. So I'm going to bring the 2 out, negative 1/2 from my u substitution stuff. So integral u to the negative 1/2 du d theta. So when I add 1 to the power and divide by the new power, it's going to be times, divide by 1/2 makes it a times 2 of, and now it's going to be just the square root of, of my 4 minus r squared. From 0 to square root 3, if you remember, d theta. If it seems like there's a lot moving along, well, it is. It's a pretty long problem, actually. Plugging in, notice that you plug in the square root 3 and the 0, you're still going to get numbers on both cases. And so the square root of, well, you got the square root and square cancel here to make 3. 4 minus 3 is a 1. And then when you plug in the 0, you get the square root of 4 there. 1 minus 2, essentially, makes it a negative 1. times a negative 1 makes a positive. Put the 2 in the front. 0 to 2 pi d theta. 2 pi slide. There we go. 4 pi in the end. Whew. That was a long problem. All right. Again, there's not very many problems on the homework for this section. If you need anything, let me know. Thank you very much. Have a great day.